introduce, my name is Taylor Thomas. This talk is called WebAssembly, a recovering Kubernetes engineer's view of the future. So I just want to start off with, the classic, who am I? I'm a director of engineering at Cosmonic. We're a startup. We work in the WebAssembly space. You'll see a little bit of what we do during this, but I am a Rustacean. I got there by way of being a gopher. And I mean, I write in all sorts of languages all the time, but Rust is probably my favorite right now. I was the co-creator of the Crustlet project, which was one of the first projects out there to try to get WebAssembly and Kubernetes to play nice together, and also another project called Bindle. I'm a serial open source maintainer in general. I'm an emeritus Helm maintainer, which I'll talk a little bit more about in a second, and I'm also a core and project maintainer for the Wasm Cloud project, which is I'm going to talk a bunch about today. So normally, I don't like to really toot my own horn too much, but I wanted to give a little bit of history about where I'm coming from. So this is kind of the slide where I explain this is why my opinion hopefully matters in this talk. I got started with Docker around like version 0.6-ish, somewhere around there. I can't remember the exact one. And I've worked with Kubernetes since 1.2. So I've been in since almost the beginning with it, done a lot of stuff. I built Kubernetes platforms before Kubernetes platforms were a thing at Intel, Nike, and then I helped build AKS at Microsoft. And I'm not trying, like I said, there's plenty of people who I built these with, but this is where I'm coming from with it. And I was a core maintainer of Helm for 4 years. And my deepest, darkest secret is that I wrote the wait flag. So if you are a heavy Kubernetes user and you know what I mean, you probably either want to throw a rotten tomato at me right now, or you want to come shake my hand. And if you're in that latter group, you probably should want to throw a rotten tomato at me because, boy, is that a landmine. Anyway, so that's my deepest, darkest secret. I've done in the Kubernetes space, but I've done this for a while. And like I said, I just wanted to explain that I'm coming from a place where I get it. I've done Kubernetes. I've done everything from controllers and operators and CRDs and built custom scheduling components and written Helm. And with Helm, I wrote a good chunk of Helm 3 along with a couple of the other maintainers. Did Helm 2 for a long time before that. So there's just, I understand this space and I understand a lot of the pain points that are in it. And so I just want to say I really sympathize with that. But I also come from the WebAssembly space. Like I said, I helped create Crustlet with my former team before I worked at Cosmonic. And I really have been involved just deeply in WebAssembly for the past 3 years. Been involved in Wasm Cloud, a bunch of community projects. And so I want to use that knowledge to kind of explain where we're going, how this works together, what things are supposed to work, what things don't really work, all that kind of stuff. I'm trying to cover all of that today. And we are going to be very demo heavy. We're going to do some explaining and then some demoing and a little bit more explaining and tons of demoing. So I did not have a ram stick with which to cut my hand to do the blood sacrifice to the demo gods. So who knows what will actually happen, but it will be a live demo for all of this. So let's go ahead and talk about what's this Wasm thing. So just out of curiosity, how many people have done anything with WebAssembly more than just read about it? Okay, that's pretty decent. That's a little bit more than I was expecting. Maybe about a quarter of the room for those on the stream. So I'm using that to kind of tailor this response to talk about what is WebAssembly. So if you've paid attention at all, you've probably seen a lot of in the WebAssembly community say this exact statement. It's neither web nor assembly. So it doesn't really make any sense, the name. It's not meant to, it's not just a web technology, and it's not really assembly, but it's just happened to be the name that it came with. And it really got a start in the web. And the reason why it was so popular in the web are these reasons right here. And to kind of dive into that a little bit, is that it's an open W3C standard. So that's kind of a basic thing for anything on the web. And so it comes from a standard, the standards group, and is supported that way. It's also safe and secure. Because this is browser code we're talking about, you have to sandbox. There's no wiggling around that. So you have to be able to work in a sandbox, and it uses a capabilities permission model. If you're not familiar with that, that's what happens on pretty much any phone nowadays. Do you want this app to access your microphone? Do you want it to access your camera? That's capability-driven permission models. Then you have the idea of it being efficient and fast. So the people who are really using WebAssembly are people who had big front-end applications. Think Photoshop, AutoCAD, all those things, they use WebAssembly to actually make that work because you're able to write the more performant parts of code in like a compiled language rather than JavaScript and then use it inside of JavaScript. So very efficient and fast for those kind of use cases. It's also polyglot, so pretty much any language can compile to WebAssembly, particularly for the browser, and that's very useful because you don't have to change your language stack to be able to write something in WebAssembly, or write something that compiles to WebAssembly is the more accurate way to say it. It's also portable because, once again, the web. You can't have something that says, oh, I work only on Linux, or I work only on Windows. It has to work everywhere, and so it's portable. Now, if we pause for a second and think about these 5 things, these are almost the exact list of things we want in server-side code. So we want it open, right? The reason the CNCF exists is because we wanted to have an open place to have Kubernetes. The reason the Linux Foundation exists is so we have an organization that can keep this thing open and managed by standards. And so WebAssembly has that same benefit. Once again, we're also looking for safe and secure. Containers got us a lot further along the line of keeping things where they're supposed to be and not being able to break them out, but it's still not perfect. WebAssembly takes that a step further. But then we start to get into the ones that are really, really interesting for server side. It's very efficient and fast. We want things that run really small, can get around to different places, and can run as tiny as possible. And the polyglot, I mean, that applies to anything, not just the browser, but also that it's portable. It can run on any operating system, which is incredibly useful. WebAssembly is one of those things that gets us much closer to the write once, run anywhere dream that we've been looking at, ever since we started trying to do things like J2EE and all that kind of stuff. We've learned a lot since then as technologists and have made it a lot more, taken a lot of those lessons to make it so you can actually take these and run them anywhere you want to. So that's a little overview about WebAssembly, why it started in the web, why it's good now, but let's talk about, well, what can it be used for then? The first big category is the general server-side computing use case. This is microservices, functions as a service. It also is very, very interesting as runtime optimization. If you want to optimize your code, and I'm talking beyond the LLVM level, which you can do with WebAssembly in pretty much any language, but if you want to decide how it's going to be optimized, you have to build it very specifically for a specific platform at compile time. WebAssembly is not like that. You can decide at runtime, for example, which runtime you're going to use, how you're going to actually do the compile pass. Are you going to do an AOT compilation? Are you going to do interpreted? Are you going to do JIT? All of that can be determined at runtime based on your device needs and the runtime characteristics you need for your actual code. So it's very, very useful for general server-side computing in that sense. It also is for constrained devices, which I'm going to very loosely put the edge, because the edge means nothing now, as we all know. It's just people like, I run on the edge. What does that mean? Oh, I run on a Raspberry Pi in my basement. And now that also falls into the edge, but when you start thinking about how, and I'll talk more about this kind of relationship, but where Kubernetes can reach to and where containers are best at, when you get to constrained devices or devices that are way out there towards the customer, think cell towers, power compute compute that's at power stations, those kind of things. That's the edge. It's stuff that's way out there. It also includes things like CDN. So it's very useful for those situations. It's also a good plug-in system. And I'll talk about this too, and more in a little bit, but I personally think that that WebAssembly has the potential to be the plug-in system to end all plug-in systems, because it is a lot better than having, most of us here have probably at least touched HashiCorp's Go plugin thing, where you write a plugin and it uses gRPC, or we use something where it's standard in, standard out, where you're calling a script and it's calling it with specific environment variables and it's expecting a specific output type. Instead of having all those kind of things, you could actually write it in whatever code you want and just plug it into code. And there's things that actually already do that. There's also this idea of using it as a library, and I'm going to show that with an example, a little picture here in a second, but libraries, there's something called the component model that is starting to really crystallize that allows you to swap out different parts of libraries as needed, and I'll explain that in just a second. And then, of course, it's great in the browser. So those are some the big use cases I just wanted to list out so people could get an idea of where you use WebAssembly. Now, as for this component model thing, I'd like to use this with Lego blocks. And Lynn Clark, who's a big contributor in the WebAssembly community, she's been around for a long time, she drew these up, and there's a really, really nice way to explain this. So with the component model, everything starts getting defined as an interface. And so this isn't just like an API boundary, it's saying like, here are the things I expect, and you can import that contract and use it, or you can export it. And so what you end up with is, let's say you have, like in this example, a tracing library that needs to use some sort of like URL library and a proxy, and then you have an auth service that has that same thing. So if you work at a big company, you probably have a huge like HTTP proxy thing set up, at least a lot of the big companies I've worked at. And let's say you're on Kubernetes or something and you're using Envoy or using any of those kind of like service mesh kind of things. Instead of having to have specific libraries that you then compile in so it uses that stuff, what you can do is swap out at runtime like a Lego block. Oh, I need the one for my big company, click. So this person using the open tracing one could actually use it inside a big company just by clicking in that little Lego brick. Now, I'm not going to go deep into that. My coworker Brooks and I, who's actually here, we're going to be giving a talk that mentions a little bit more about that concretely tomorrow, but I just wanted to bring it up that that's something that's really, really cool about WebAssembly right now. Now, what are the pain points? Thank you, Gordon Ramsay, first off. But the first thing is networking is still difficult, especially on server side. We're just getting socket support in, and it's going to be landing very soon, but like it's a little bit difficult to do networking at like the raw WebAssembly level. And also, things are very much in the fast-moving stage, just like things were at the beginning of Kubernetes or Docker or any technology trend. We're in that phase where things are breaking and evolving very, very quickly. So if you're not tolerant to that risk, then that's something that could be a big pain point for you. It's also slower than like native code, as in execution speed. So no matter what you do, you're not going to get the exact same performance. But for people who are running things in Kubernetes, that level of performance doesn't really matter because you have a network layer in between it, right? Like between you getting something there and coming back, that doesn't matter too much. But if like really, really like low-level performant code is a need, there's still some work to be done there with WebAssembly. And I don't know how far we can eventually get that. I'm not as good at that low-level stuff. The other thing, especially for server side, is tool chains really aren't there in some languages. I'll just be blunt right now. Java, like true Java without smoke and mirrors and special libraries and hacks, probably a while out. But a lot of other things like Python, Lua, interpreted languages are getting support right now for it. So that's just one of those things. There's some languages that don't really compile very well to WebAssembly that can be run on a server. So those are the pain points there. Now, I mentioned Wasm Cloud at the beginning. Wasm Cloud is a project that I work on. It's entirely open source. It's in the CNCF. And the question here is like, well, if WebAssembly is so good, what do we need Wasm Cloud for? Or any other thing like that? Well, there's this conversation, what is a runtime versus an application runtime? A runtime in this case is, think more along the lines of like a Docker type of thing. Docker is a runtime. It doesn't let you, you're not building applications on top of it per se, it just runs code that you have put into a container image of some kind. That is all that Docker is doing. It's a runtime level thing. Application runtime is something that can actually run an application at scale, do it between different things. And what Wasm Cloud really focuses on is distributed capability-driven development. So those those components thing that I was mentioning before, we do that at a distributed level and not just at a code level. I'm plugging it together. So that's a little bit about Wasm Cloud. So to explain what that actually looks like, we're going to start with a basic demo right here. And we'll go ahead and show, I'll just go ahead and show this. So I've already spun up what is called, this is what we call the washboard. It's the Wasm Cloud dashboard. And this is just the simple thing showing, I'm going to run a simple demo, and a simple demo application. This demo application is going to be at the heart of every other demo I'm doing today, but I want to show you how it works first. So this is a KV counter. The whole purpose of the KV counter is to take a request, and it'll take the path and use it basically as the key, and then it'll increment a counter in a key value store every single time you hit that URL. Now, the nice thing about this code is we can come in and look at this code that we have for the example, and I'm going to just point out, this is Rust for those who are curious, but like it doesn't really matter. We're not doing anything complicated, and hopefully the internet's going to work. If not, luckily I have the backup because, like I said, angered the demo gods if I didn't do the blood sacrifice. So the thing that happens with most code nowadays, if you're doing a project, like think Kubernetes, since we're Kubernetes Community Day, I take a project and I say, Okay, I'm going to build like my cat blog. What do I need to do my cat blog? Okay, I need an HTTP server. So I go copy paste that exact same 10 lines of Go server code that I have done for a bajillion years, and I copy paste it in my new project. And then I say, okay, well, which database am I using? Well, I want to use like Redis, or maybe we're in Amazon. I'm going to use Amazon. You have to put it all together, then you build it. Then you have to define your Docker file. And then once you built your Docker file, okay, am I using Helm? Am I using Customize? Am I using Scaffold? Like, what am I doing? And then you have to put that together, and then you have to deploy it. It's very, very long, like, to put that all together, when all you're trying to do is just write like a simple like cat blog, right? It's create, read, update, delete, and that's all you have to do. And so what you'll notice in this code, like I said, you don't even have to know Rust to really understand this code, is you have this thing that says, hey, I'm an HTTP server. I don't care what HTTP server is giving me these requests. Oh yeah, sorry, let me zoom. Ta-da. So this just says, I'm going to take an HTTP request and do something with it. And then down here we say, okay, I'm going to increment a counter. You'll notice there's no connection strings, there's nothing in there. It just says, hey, I'm going to send this key value thing and increment it. That's all the code is. So in total, we have 49 lines of code to do all of this. Most of the time you try to do this in any language, you're going to be at least 100 lines of code as you have your server set up, your configuration values, all the different things. This code is exactly like this everywhere it goes. It's compiled to WebAssembly and then can run on any operating system. And so when we come back to this dashboard, we'll see that's the code that's running right here. Now, we've also started something that we call them providers because they actually provide the functionality. We've provided something that can satisfy the HTTP server contract, and I'll plus this up for people. And then something that can satisfy the key value contract. I'm just going to use Redis for this one, but you can use any number of things for this. And then to put them together, all I have to do is at runtime I say, okay, I'm going to link my KV counter with an HTTP server, and I'm going to say this is, and I'm going to set an address, if I can spell address right, to 0.0.0, 8080. Okay, so this is just going to listen on an 8080 port. So all the configuration is now handled when you link it together. And of course, there we go. Run that. So now it's running it's now running a server for me. But I also need to give it the key value store that it needs. So I'm going to do the same thing here. And I'm going to say KV counter, Redis key value store. And then I'm actually not going to provide any values because it'll default to localhost. And I just have a Redis server running locally. We'll show you how this actually looks when you have a Redis server running somewhere else in a second. Okay, so now this is all connected up and ready to go, and I can come over here to localhost 8080, and you'll see that there's a counter. And I'm refreshing it, and it can update and do all those things. So this code didn't need to know what database it was talking to. It didn't need to know any of those types of little pieces of information. And why is this important for me? Well, number one, updates. Think about what happens with like a log4j, right? Log4j happens, and we all write bugs. Let's be clear here. If you haven't written a big bug in your life, please let me know. I'd like to know how you manage that. But most of us, we've always written some sort of big bug, so there's always security updates. When that happened, we've talked to multiple people about this. They end up redeploying like 10,000 applications, rebuilding and then redeploying. In this situation, all you do is update the provider and swap out the provider, and you're done. And so that's a really, really powerful feature of what being able to do this distributed does for you. We even did it for ourselves. We started writing something. So our entire Cosmonic platform is written on top of Wasm Cloud. And we started writing things out. We're storing some data in Redis. And then we're like, well, some of this is secret data. We need to make sure we actually store it in a secret place. We implemented this key value contract for Vault, as in HashiCorp Vault, and then just swapped it out without even needing to change our code. And poof, we had security things in place. No change to code. So that's just the simple demo. We're going to show some more complex stuff down the line. But I want to talk about the conversation why most of you probably hear, well, what about Wasm and Kubernetes? And that's where I'm going to really show some cool stuff. But let's bust some myths first here. To answer the question, is Wasm going to kill containers? The answer is no. I'm not sure, you've probably seen that debate. I mean, I'm sure it's popular on Twitter. I'm sure it's popular wherever. It's not going to kill containers. There are certain types of applications that just, like, no one's gonna go rewrite Redis to not run it, like to run in web. It's just not worth the effort right now. That works great in a container. There's multiple, like, just think about any of those big applications that have been around for a while. Those aren't gonna go to WebAssembly anytime soon. They play along with each other. Things are evolutionary. And I'll mention that a little bit more when we bust some of these other myths. The first one is, hey, I should just run some Wasm in my containers. That's a very common one, like, oh, I just want some Kates in my Wasm. The problem is you lose a lot of the advantages of having that. Like, you already have the sandboxing, everything you need, and being able to run cross-platform, and then you end up taking it and putting it inside of a Docker container that can probably only run in Linux or something that's shimmed for Linux. And you have the overhead of starting up the Docker containers and the overhead of starting up the WebAssembly. It's not worth it. And I'm going to mention some other stuff that actually uses this stuff right now as, like, basically a Docker replacement. But yeah, you don't generally, it doesn't mean you shouldn't, it just means, like, that shouldn't be the first thing, like, you think of, like, oh, that's how I'm going to use Wasm for real. It's fine to play around with, it's fine for specific situations, but just, it's not like it's adding an extra layer you don't need. And then the last thing here is that, oh, Wasm and Kubernetes are and like the various runtimes of Wasm are in competition with each other. Also a big no. This is all a better together story, and I'm going to show that very clearly in my next demo. But everything's evolutionary. Just because we came up with virtual machines doesn't mean we don't have the need for physical hardware. Just because we came up with containers doesn't mean we don't need to worry about or use VMs, and so on and so on and so on. So WebAssembly is just another evolution. Just because we have WebAssembly doesn't mean there's now no longer a need for containers or Kubernetes. It just means there is an evolution where it can be used for certain types of tasks better than others. So what can you do right now with Kubernetes and Wasm? First off is the wonderful Run Wazi project. That was started by some people at Microsoft and then a couple other people in the community. And this essentially allows you to run, like, the container shim inside of Kubernetes using a WebAssembly runtime. Like I said, that's the better option than trying to run your Kubernetes, running your Wasm in, like, a container inside of Kubernetes. This actually runs WebAssembly directly, just like it would be running a container if you spun up a container in a pod. So highly recommend checking out that project. That's one way you can do it. Also, service meshes, anybody? If you didn't know, things like Envoy and other service meshes already have the ability to write plugins using WebAssembly. So it goes back to that plugin model I talked about, and so you can actually write custom filtering and other plugin models using something that's compiled to WebAssembly. And then you can also use Wasm Cloud, which is what I will be showing in just a little bit. So here's the opposite side, and I know this talk is meant to provoke discussion, so some people might vehemently disagree with me here. We have plenty of hallway track space to talk after, and I do want to talk. So one of the things is that it runs smaller. If you really think about it, the default pod limit is 110. Let's just say that your crazy, complicated environment has a bajillion sidecars, and there's actually 5 containers in each of those pods. That's 550 containers that a single node can run in Kubernetes. Now, I know that's oversimplifying it. There's things you can tweak. There's stuff you can increase. I know. But just from, like, the basic, I'm running this at default, there's a limit there. But then also, you get, with WebAssembly, a lot more in that. Pretty much any WebAssembly application runtime right now can run thousands of WebAssembly modules, if not tens of thousands, on a single node, depending on the node size. On this laptop, I think I've maxed out around 3,000 or 4,000 or 5,000, somewhere around there. Just a normal Mac laptop. So it runs a lot smaller, and that's just really helpful. We've talked to several Fortune 100 companies about this stuff, and their Kubernetes server utilization sits around 25 to 35% of their total capacity. And there's some that it's so bad they've actually spun down their internal Kubernetes teams that were running it just because it's so expensive. And so WebAssembly allows you to pack a lot more into a smaller space and get better utilization out of it. It's also entirely sandboxed. Containers are pretty tight, but you have to, there's a lot of, like, little security nuances and things. By default, a WebAssembly module can do nothing unless you grant it the privilege to do so. It's also cross-platform, and what I mean by this is we've been telling ourselves a lie for years. Docker is not cross-platform. It is, but it isn't. Windows containers look entirely different from Linux containers. And I knew a lot of those people when I worked at Microsoft. They do amazing work. It's not a knock on that work, but you have to have one for Windows, you have to have one, and on Mac you're just running a VM, and on Linux you're actually running a Docker container, but if you're running an ARM processor, well then you need a different Docker. That's not cross-platform. WebAssembly is cross-platform and does that a lot better. And as people start, so you start getting things, like the Graviton processors from AWS, and people are building their own silicon, and there's all these different things that are going on, you're getting a lot more heterogeneous environments, and that becomes more and more critical to have something that can run everywhere really easily. Once again, I'm going to bring up the edge. I will take questions at the end. Yeah, I'm saying. So the edge is the other big thing here. Is this question of like, well, where can I run it? Most people you talk to know, I'm going to first call out as a huge positive, K3S is a wonderful project. I'm guessing a large chunk of people in here, including myself, run that in our own home labs or our own. We all do that. It's an amazing piece of software. But the thing is you can only go so far to the edge. A lot of those types of companies that we've talked to, like the power companies and cellular companies, it's really hard. Kubernetes likes to be in the same cluster, in the same region, across availability zones. That's what it's good at. It's not really good at pushing out where you have either sporadic connectivity issues or whatever it might be. And so moving out to the edge, WebAssembly allows you to get to that edge a lot easier. And the other thing here is this lower bound problem. I kind of invented this term. Don't try to use it for real, because then I'm afraid people are going to be like, where did that term come from? And I don't want it to be me. But this is a combination of the idea of a cold start versus just where you have to run things. It takes a little bit for things to spin up inside of Kubernetes, even if you have the image cached. So not only do you have the cold start time, it's getting it close enough to your customers to avoid the perception of being slow, even if it's not actually slow. And so WebAssembly has a lot quicker startup, and because it's smaller, it's easier to download and get started when things are going. And you don't necessarily have to keep things like hot containers up. So it's just that these are just a couple things that I wanted to mention that WebAssembly does better than Kubernetes, but the thing is they still play well together. So just one little thing to finish off before we go into the next demo is a possible view of the future. And to be clear about this is not the actual future, this is the future according to Taylor. So I could be 100% wrong on all of these, but I'm just going to put a few predictions out there to get people thinking about it, and whether or not this could be true or no, that's totally dumb, Taylor, just shut up, you're wrong. Either one of those is an okay response to any of these, but the first off is I personally think all functions as a service platforms will become WebAssembly based. You don't have to worry about, like I said, the hot container thing where you have to have a hot container that can run certain stuff. You don't have to worry about getting those containers close to the users so that it's fast enough for them. And WebAssembly is just going to, because the polyglot nature, you don't have to okay, well, yay, we've added support for Rust functions, and yay, now we've added support for X language functions. That goes away, it's just whatever WebAssembly supports you can run. So I think that all functions as a service will be that WebAssembly based in the future. I also think that true microservices will become Wasm modules instead of containers. What I mean by true microservices is I'm not talking about that lift and shift 20 gigabyte container that you pulled your Java app from and you're running with 16 gigs of memory. That is not a microservice, as much as we like to sometimes call it that in the internal business meetings. I'm talking about, oh, this is my user service, and this is my pictures service, and this is this service. Those kind of things, those isolated units of business logic will become WebAssembly more often than they will become containers in the future. Like I said before, I think that WebAssembly becomes the plug-in model to rule them all, and that component thing I mentioned is kind of the key there. You can have an interface you define, anything can implement the interface, and it can just be dropped in. And then I also think that newer waves of platforms or tools are going to be built directly on top of WebAssembly. Obviously, I'm biased here. Cosmonic is built on top of the awesomeness that WebAssembly provides it, but I think that a lot of new tools will be built directly on top of that layer to really provide some good experiences and things for users. So like I said, could be 100% wrong, and we'll see what happens in a few years, but this is something to maybe start thinking about. What's the future look like? So let's actually see this in action. This is the demo that I'm pretty excited about. So I just want to review. This is what I showed you earlier. I had something running on my laptop. I had a provider that was receiving an HTTP request, a counter actor that was receiving it, and then that was making a request to Redis, in my case, to increment a key value. So let's go ahead and show you what we're actually going to be doing. We're going to start off with this. So I'm going to be showing how this works in Cosmonic, because Cosmonic has a really nice dashboard to look at. Everything you see here today is 100% doable inside of open source, just to be clear. There's not a lot of things like that I'm doing magic that's just specific to Cosmonic. It just is a good way to demonstrate. So we're going to start off. I have a Kubernetes cluster running in DigitalOcean, and I have a Wasm Cloud host that's running inside of Cosmonic. It's hosted by Cosmonic. And I have a little container that I have sitting around that I'm going to show you as if it were an internal service calling, like that you have running inside of Kubernetes. And on this host, it's going to be able to receive an HTTP request, which is those 3 lines on step 1. It's going to get that, send it to the hosted KV counter, that same code that I showed you before. And then that KV counter is going to call a Redis database back inside of Kubernetes. So imagine if you had, like, your service, you already have Redis that you use for all your services inside of Kubernetes, or a good chunk of them, and you have a service that's already consuming something, a bunch of things internally inside of your Kubernetes cluster. And this is saying, I just want to write one little new piece, and I'm going to write it in WebAssembly and run it in Wasm Cloud. So that's this first demo that we're going to show, or the first part of the demo. So what this looks like when we do this for real is, let me go ahead and refresh this. We're going to hope the internet works again, because we all know, cross your fingers. I'm going to get the internet backup ready just in case. Aha! It heard me threatening. Okay, and then over here, you'll see that we have these things labeled as Kubernetes. These are running as pods, in case you want proof that I'm not just faking this. Oh, yep, sorry. We're going to have to... There we go, big enough. You'll see that there are 3 containers running. This is using the Helm chart that we release. I did discover a bug, so I have to release that bug fix. But all I'm doing is 19 lines of a values.yaml file to be able to start this up, and I'm connecting it into this cluster. And I will, there we go. So it's just, like, basically I've just set a few config values and started it up. So this is actually running. There's 3 of these nodes. They're all labeled. And then I have a Cosmonic managed host like I was describing before. So I have this KV counter. And this KV counter is sitting there, and it's connected to a Redis thing that's running and the HTTP server that's running. And so if I come back here, and I'm going to go into my, where did my, of course it didn't. Give me a second. The network decided to shut down my command prompt. And I have to reinstall. This is proof that I am not canning this demo. I am literally installing curl in front of you. Come on, buddy. That'll take just a second because this isn't running inside of this conference center. Okay, so then it should be right there. So while that's happening, I'm going to show you. I have a service in here that I'll demonstrate a little bit later that actually has all the anytime there's a service created, or a new, like, basically one of those links is created, it automatically creates a service for it inside of Kubernetes. So, and it's actually, so that's an actor, it's a WebAssembly actor that does that. So I'm just using it by default, the default, like, thing that I have set up, so it's just using the ID of the thing it's connected to. But I'm going to go ahead and say curl, and it's going to call it on port 8080. Okay, so that's incrementing a counter. So that's going, this DigitalOcean cluster is sitting in New York. It is going to something running in US East, and then calling data that's back inside of that cluster, and then sending it back all the way through. So that's just the first one. That's the first simple thing. Now let's go back to this and show you what we're going to change it to now. So we have this. Now we're going to go to this. So I'm going to connect my laptop in, and I'm going to move that code from the thing running in US East down to my laptop, and everything else is still running inside of Kubernetes. So I'll go over here and show how this works. We have a nice little thing that does this for us, but I'm going to, like, basically kill what I was already running, and I'm going to say Cosmo up. This just does some, it's a shorthand for, and internet issues. Of course, we'll give it a second to try to catch up. Of course it won't. Okay, we wire in, everybody. Well, we'll see if not. If not, I have this canned just in case, but okay, well, we'll pull up the can because the internet. So you'll see a similar thing right here, and we have that KV counter right now. And we'll come back to my machine. Sorry for the small text on this one. I can't really increase the video size. And I'm running that Cosmo up. So it's going to put everything in, glue it all together, and then I'm going to have a host running. And when I come back, you'll see that it actually starts up and has the thing running on there. So when we're going to go ahead and take this, we're going to stop the code we were running on the Cosmonic hosted node. I don't know why it keeps going like that. And we're going to start it on my Mac. So once again, same exact code. It gets launched into my thing, and it's started, and it's all connected. You'll see it's all reconnected to it. Everything's working just fine. I did do this from my hotel room, so it was still in Pasadena, and it's entirely unmanaged. So this is all in these things I've connected in. And if I come back into that container, I can curl it, and I can see that counter is continuing to increment from the same data store. So what we just did was, like I said, move it over in that diagram to what we were doing with this. And let me try one more time since we're here. Nope, not going to happen. So that's what we did. Now we're going to go ahead and move on to the next one, and I'll make this big. So now we're going to change it a little bit. We're going to say, you know what, like, I don't want to use Redis for this one anymore. I'm going to use the built-in key value store that Cosmonic provides. It could be any other key value database, just to be clear. It's just easy to do this one. And then I'm going to go ahead and do that over here. We're going to keep the actor running on the Cosmonic one for now, just because of internet issues. And then I'm going to say, you know what, I'm tired of using this key value store over here now. I'm going to delete it. We'll see if the internet doesn't work here, I might not be able to do it here and have to. Oh yeah, we're down. We down. Let's try slow. Just make sure it's back. I don't think so. Nope, not working. Okay, while we try to figure that out, this is exactly why I come with the backup. I'm going to try it one more time. Aha! Instant success. And we'll even try this over here. Maybe we can get it back to normal. Yes, there we go. Thanks, everyone. The internet. Okay, so now that we have internet, we'll give this a second. There you go. Popped up just to prove I didn't just do that with smoke and mirrors. And I'm going to go ahead and move it over so we can see the next part of this demo just fine. So I'm going to say, okay, KV counter, I don't want you on here anymore. I'm going to move you over to my Mac OS one. Okay, that's now starting connected. But now I'm going to say, I'm going to just get rid of this key value one. That's now gone, and I'm going to say, okay, I have this built-in key value one. So you'll see, this code is the exact same code. I haven't changed anything in it. And now I've connected it to the key value store that's in Cosmonic. So, review of where we're all sitting. New York is where I'm making the connection from. I'm coming back to I'm coming over to have the logic that actually handles it be here in conference now wired network instead of Wi-Fi. And then it's going to talk to a database that's running in US East and do all of this. And once again, 0 code changes, 0 architecture changes, nothing had to change at all there. Now we're gonna see if my pod is still up. It probably isn't. So we're gonna make sure we've, okay, perfect. And you'll have to see me install that again because I can never remember the curl pod. Okay, and here we go. Perfect. Or not. There we go. Okay, curl. Go back and grab that service name one more time. Okay, you'll see that the counter changed. We were at like 14, 15, 16 before, and so that counter changed again. So I just swapped databases like it was nobody's business. There was no migration. I mean, you wouldn't do that for real in a real production thing. Please don't. But you can swap out and change these things out. And so I was just able to completely re-architect my application across 3 different locations in the United States by doing that. So let's go ahead and say, let's just take it one step further. So I'm gonna go and show you this one, blow it up for you for a second. We're gonna change it a little bit. And what if you have a service, an actor, and this could be something that's actually just calling back to a service you're running in Kubernetes. I'm making it an actor just for simplicity. I'm just gonna start this echo actor. This is just a simple thing that echoes back the request to you just to show that it works. And we're gonna use something we call wormhole. That's the ingress point for Cosmonic. So we're gonna come in through Cosmonic and route stuff over to Kubernetes without any like extra changing again. But I'm also gonna show you how we've built some things to integrate with Kubernetes really easily. So we have this thing called the service supplier that does that automagical like creating a link for you. And so if I come here and I say, I can actually use that. I'm just gonna run this on Kubernetes too because we can. Okay, so we'll go ahead and start this up. I already linked it with everything. And so now if I go ahead and start the echo actor, I'm gonna start it inside of Kubernetes again. Just to show that, there we go, Kubernetes, true, find hosts. So we'll go ahead and start it over here on this one, and it's all created. And then I'm gonna say, you know what, I'm gonna link this over to the HTTP server. So this is if I was linking it inside so Kubernetes could reach it. And I'm gonna say address is 8081, create the link. And if I come back over here to this and I say kube control get service, you'll see that it automatically created this port 8081 for me. So basically, it's a constant compatibility with whatever you're running in Kubernetes and then what you can run inside of Wasm Cloud. So we're gonna actually delete that. I'm gonna change it to the wormhole that I showed you. And we can actually go back and check that in a little bit if you want to and see that it's gone. But I'm gonna say, let's link this over to the wormhole. And I'm gonna say, create link, and create the wormhole for it. I think I still have some stale state from when we had network issues. Okay, there we go, perfect, withered voice. So I'm gonna access this, give it a second. Okay, so what I just did is now I'm getting something from right here on my machine, going to US East, forwarding through to my DigitalOcean cluster in New York. So this is just if I wanted to send something to a service I had running inside of Kubernetes. And you can see just that I'm not making this up. I'm gonna pass a query string. You'll see that the query string it echoes back got changed. So this is all set up to be that way, but we can also show the idea of automatic failover. So this idea of having like cross-cloud backups and failovers has become more important in recent years, especially in regulated industries like banking. So what I can do is like, let's just simulate. I'm gonna like pretend like, let's say the node went down or Kubernetes had an issue and now this actor is being terminated. And then I'm gonna go ahead and refresh that so it shows everything clear. And so we don't have the echo actor anymore, and I'm gonna say, now we have it running back over on my Mac. If I can actually click buttons. Okay, so it's going to launch that for me, and it might also, we might be having networking issues again, but we'll see. Okay, we are. So anyway, the whole idea, you kind of already saw this before, I can move it around and change it and have it come back into my laptop from the internet, talking to Kubernetes. There's all these different things that go along. So to review, we went from basically this locally to being able to distribute it across 3 different nodes and move the app around. So everything stays compatible. This is the idea. We want it to be a bridge to the future. We don't want people to have to like do something different. You can still be doing Kubernetes. You don't have to like just say, no, we have to go wholesale over to WebAssembly. If you want to try it out, you can try it out right now. So some examples of what you could do basic data, image, processing type stuff, just a simple service that you could run over that's kind of isolated. You could also try one small part of a service, like I was simulating this time. Build one thing that can compile down to WebAssembly, have the rest of your stuff still running in Kubernetes. You can also, if you're trying something greenfield, do a full like stateful application as well. So with that, I just want to put these up there. This is a link to our landing page on the right, our Slack on the left if you want to come talk about this and try it out. We'd love to see you, see what you're trying to do. And I think for that, we will now go to questions. Plenty.
Thank you. I guess I get to kick off the Q&A session. So, I mean, the demo was cool. Thank you for the talk. Taking aside the advantages of Wasm, right, like bin packing, right, sandboxing, and so on and so forth, a lot of the stuff that you were showing, right, like how much of it is just like sugar that's been built by like Wasm Cloud and your company, like Cosmo and that kind of stuff, right? Because all of that flexibility around relinking and like parameter passing and so on, I mean, right, like how specific is it to Wasm? Like you could conceivably build a similar platform on any tech that exists, right? And have the same nice GUI, ease of use, and so on.
Yes, you could build, so like underlying, we're completely open about our tech stack. Underlying this is Nats, which is another open source one, right? You can use for anything you want. But what is different is that WebAssembly allows us to do this pretty fearlessly across any operating system and architecture. So you can join, like I just joined my MacBook to this and had it work. And yes, you could make it work, but WebAssembly makes a lot of this easier to do because of its portability and its size. So that's the thing. It's built, just like building any platform, you could build this using another set of technology. What we have in Wasm Cloud in particular is a combination of leveraging WebAssembly and building that kind of platform.
So this doesn't have so much to do with Wasm Cloud, but it has to do with you know, the future of like, you know, where this could take where Wasm can take web development. So still, if you want to build applications on the browser, from what I understand in the past, or from what I understand even with Wasm, you still have a single thread that's responsible for rendering in the browser, and that single thread still has to be controlled by JavaScript. So it's not the case that you could now, using Wasm, use any language that compiles to Wasm to actually control rendering in the browser, allowing you to do the same language for the backend as you do in the front end for an arbitrary language. Yeah, so the thing with WebAssembly right now is it is single-threaded. There's currently proposals in place to make it multi-threaded and to go further through that. So that can be done, but yes, right now you're talking about one of the specific underlying limitations that does happen, and it definitely does exist, and it's good to call
out. What does debugging or tracing through an application in the Wasm world look like?
Yeah, so tracing is not too difficult. I don't have time now just because we're running shorter on time, but we actually do that. We have it built in by default to the Wasm Cloud host. Everything gets traced. Every call to these things, you can export it to OTLP type stuff, and it works great. Debugging is a little bit more of an open story, but because it's a common format you're compiling to, I imagine that we'll be able to create a new wave of debugging tools that can then debug something from any other language that is compiling to WebAssembly. That's what I'm hoping for, at least.
Okay, one more question. Nope.
We have a couple over there, yeah.
Do you see a lot of use cases for running untrusted code, like third-party libraries and stuff with Wasm?
Yes, that's actually one of the main things, is because you can, all of this code right here that we're running that I was just showing is untrusted code. And that's another thing I guess I didn't point out to his question, is that like, because of the security benefits of WebAssembly, we have a bunch of signing and some really defense in depth stuff that's kind of cool. We'll be talking about, we've talked about before, you can look up some of those, but you're able to run completely untrusted code from anybody on the platform without too much extra hassle, really, in comparison to some of the other ways you'd have to do it.
Okay. Awesome. Well, thank you very much.
Thank you.